Hello everyone. In this video, we will learn linear equations with two variables. So when we talk about linear equations, we are talking about a straight line on the Cartesian plane. Okay, so the word linear here is very important. Linear representing a straight line. So if we talk about Cartesian plane, it means that we are talking about the coordinate with the x and the y axis. Okay, so the two variables in this equation are the x and the y. So if we are talking about equation, then we say, okay, I want to solve this equation with one unknown. Okay, so then that means you only have x or you just have the y. But in this equation, it's involving two variables of x and y. So it's called linear equation or it's called linear function because the x and the y are the coordinate that you find on the Cartesian plane. And if we are talking about linear equation in general form, it will take on this form, ax plus by plus c equal to 0. So whenever you see a linear equation with the two variables presented like this, ax plus by plus c equal to 0, where a, b, c are integer, then this is called the general form of the linear equation. Okay, the linear equation needs to be true to its statement. What does that mean? So this means that if you have an ordered pair of the x and y, you substitute into this equation, it should equal to 0, given that you have the value a, b, and c. Okay, a linear equation can have more than one solution. So another characteristic of the linear equation on the Cartesian plane is that it can have more than one solution. So what does it mean by the solution here? These solutions or the x and y coordinates can be plotted on the Cartesian plane and they can be connected to make a straight line. Okay, so this solution or the x and y coordinate can be plotted on the Cartesian plane and they connected to make a straight line. So when you connect all of the solution to make a straight line, so this straight line is your linear equation, then that means that on that straight line you can find all kinds of solution for this linear equation. Okay, so let's talk about a particular linear equation with the values that we are going to see. So for example 1, given the following general form of the linear equation and its given graph as 2x plus 3y minus 12 equal to 0. So the first thing you want to do is you want to rearrange the equation to 2x plus 3y equal to 12. And what you are going to do is we plot and examine the following order pair 6, 0, 0, 4, negative 3, and 6, 12, and negative 4. Okay, so we want to see if this pair that given to us actually line up on the graph. If they are lined up on the graph, then they are the solution of the linear equation. So if we can find two more solutions for this linear equation and if we can prove it. Okay, so what I have done here is I already sketched this graph using a graphing software. So I have x and y axis as a Cartesian plane, and on here I have this straight line. This is a linear equation, continuous here, continuous further up, continuous further down here, and I am going to plot and examine the order pairs. Okay, so first of all, I will take a look at the 6 and the 0. So the 6 is the x, 0 is the y. So take a look at this. 6 is the x, 0 is the y. So this must be the point. Okay, so let me label that in blue for everyone to see. So this is the 6 and the 0. Okay, so let me write it down, 6 and 0. Okay, the next one is 0 and 4. Okay, so that means 0 is for x and 4 is for y, so which is this point right here. Okay, so this is 0 and 4. So I will see that is they are right on the straight line. Now negative 3 and 6. So I will look for x as -3, and I project it up here. I saw 6 is right there. So right on the graph. So this one is -3 and 6. Now the next point is 12 and -4. So 12 is for x, so I'm moving down, and then I meet that here for -4. I project it out, and here's my point, 12 and -4, right on the straight line. So 12 and -4. Okay, so these are called the solutions for this linear equation. You see, all of this point on this graph here will be the solution for this linear equation. Okay, the above order pairs are lined up on the graph, therefore they are the solution of the linear equation. So this linear equation, let me label it for everyone to see. This entire equation here is 2x plus 3y minus 12 equal to 0. And this is the general form of this linear equation. Okay, so this whole graph is 2x plus 3y minus 12 equal to 0. So what they ask us to do next is, can you find two more solutions of this linear equation, and can we prove it? Okay, so that means I am going to click a point on here, and I try to see whether or not it's lie on the graph. Okay, so I am going to click the point here. Let me try this. So this one, I'm going to use it in red. Okay, so this one, 15. Let's project it down. Right there, I see that this one I can read it as 15 and -6. Okay, 15 and -6. See that? Okay, so it asked me to, can I prove that this is the point on this equation? It means that you substitute the value of x into this equation, you substitute the value of y into this equation, and then you perform the operation to see if it's true to its statement. That means if it's equal to 0. So let's try that. Okay, so I'm going to get 15 and -6, and then my equation is 2x plus 3y minus 12 equal to 0, or I can say that it's equal to 12. So I can check the left hand side and the right hand side. Okay, so this one is the x, this one is the value for y. So where the x is, I will substitute in the value for 15. Where the y is, I will substitute in the value for -6. Okay, so this is equal to 30 minus 18. So make sure that you perform the operation obeying the order of operation, which is best math. You multiply first before you add. So 30 subtract 18, I end up with 12, which is equal to the right hand side. So left side equal to right side. So in this case, it is true to its statement. So this point is right on the graph. Okay, so we can find another point. Okay, so this one is okay, right on the graph. And then we can find another point. And what I'm going to ask everyone to try is to take a look at this point right here. Okay, so this one. All right, okay, so let's see that. That should be -6 and 8. Okay, so let's try -6 and 8. Right? Okay, -6 and 8. -6 is for x, 8 is for y. So x, y. So let's get to the equation. 2x plus 3y equal to 12. So let's see. 2 multiply -6 plus 3 multiplied by 8, let's see, is equal to 12. So this one is negative 12 plus 24. 3 times 8 is 24. 2 times negative 6 is negative 12. And this should give me 12 equal to 12, right? So this point is actually on the graph as well. We look for the point on the graph. We substitute into the equation to prove that the equation is true to its statement. That means the left-hand side is equal to the right-hand side. Alright, so this one I would pick it as negative 6 and 8. Okay, this point right here, I was picking it as negative 6 and 8. Alright, so let's continue to see what we have to do next. Alright, so for this question, I am giving you a linear equations. Okay, determine if the given coordinate are the solution for this one. So we have 6 and 0. So let's get started. That means that you are going to substitute each of this pair into your equation to see if the left-hand side equal to the right-hand side. If they equal to negative 18, then that coordinate here is the solution for this equation. Okay, so I will put in negative 3, and then where the x is, I will write 6, and plus 5 times 0, is it equal to, what is it equal to? So negative 18 plus 0, so equal to negative 18. So this one is the true. Okay, so the true one is actually the one that the solution for this equation. Now negative 6 and 0. Okay, so let me alternating the color. Then what I will do here is this is x, this is y. Okay, to make sure that we remind ourselves. So I am going to put in the negative 3, and then I multiply with negative 6, and then I add that with 5 times 0. So in this case, I have negative 3 times negative 6 will give me positive 18. And this one is not equal to negative 18. Okay, so this is not the point on the graph. So we can simply put the word no here. Okay, so this is not the solution for the linear equation. And the next point is 1 and 3. Okay, so don't forget it's x, y. So I'm going to substitute that into the equation. Is negative 3 times that by 1 plus 5 times that by 3. Okay, times that by 3. Alright, so this one is negative 3 plus 15, which is equal to positive 12. Then it's not equal to negative 18. So this one is also a no. Okay, so this point 1 and 3 is not the solution for this linear equation. This point negative 6 and 0 is not the solution for this linear equation because it doesn't prove that both sides equal to negative 18. Okay, so this one positive 18 is not equal to negative 18. This one positive 12 is not equal to negative 18. So let me circle the one that is the solution for this. So this is the solution. So that's 1. Okay, and now we are going to try for the next point, which is 1 and negative 3. So then I will write negative 3 times 1. So reminder again, this is x and y. Negative 3 times 1 plus 5 times negative 3. Okay, so this will give me negative 3 subtract 15, so give me negative 18. Okay, so this one is true. Okay, so this one is true. Okay, so this is another point on the graph. Alright, okay. So it's true, this is a no and a no. And the next one is -4 and -6. So -4 and -6, again, I will substitute it into the linear equation. So -3 times x, which is -3 times -4, and then plus 5 times y, which is 5 times -6. So this one should give me positive 12. Subtract 30. So this one is equal to -18. So this one is also true. So the point -4 and -6 is also the solution for this linear equation. Alright, so for the 5 points that they asked us to check, there are 3 of them are true, okay? And if it's not equal to -18, then it's not the solution for this linear equation. Alright, okay, so it's very simple. According to the definition, we need to prove that this linear equation stays true to its statement. Okay, so now you see this linear equation has lots and lots of solution. Depends on the pair that given to you. Alright, okay, so let's move on to see what they ask us to do next. Okay, so we need to plot the solution on the Cartesian plane and connect them. They should line up and form a straight line. Okay, so then which one is the solution? Right, so the solution for here we only have 3 points, which is 6 and 0. So let's find the 6 and 0. So I'm going to write down the point that is true here. So I will have 6, 0. I will have 1 and -3. And I will have -4 and -6. These are the true. Okay, so these are the point. And the point that are not true will be -6 and 0. And then 1 and 3. So I want to prove that these points will form a straight line. So that means that if you connect these 3 points, you will have a straight line. Okay, and these two will stay off the graph. Okay, or that means they don't stay on the graph. Okay, so I should reword that. Okay, so these points will not stay on the graph. Okay, just to be clear.